Hello everyone. In my last video on determinants, I explained the properties of determinants and solved a few examples using those properties. Now, in this video, I am going to solve some more problems. So, our first example is without expanding, find the value of this determinant. Now, I have marked this phrase without expanding because this is very important. If without expanding is mentioned in the question, you cannot expand at any step. So what we can do here is we can try to make two rows or two columns identical. Especially in this type of problems where without expanding will be mentioned, you will try to make two rows or columns identical, because we know that if we can make two rows or columns identical, then by one of the properties it will the value of the determinant will be 0. So our target will be to make two rows or columns identical in especially this type of problems where without expanding will be mentioned. Okay, so let's see how we can make two rows or two columns identical here. You see that here if we apply the operation R1 changes to AR1, that means we are multiplying first row by A and second row by B and third row by C. So if we apply this operation, that is multiplying the three rows by A, B, C respectively, what we will get? We will get multiplying the first row we have multiplied by A, so it will be A, it will be ABC, it will also be ABC into B plus C. Now here it will be second row we have multiplied by B, so it will be B, here BCA, that means ABC, here also BCA, that means ABC into C plus A. Here third row is multiplied with C, so it will become C, CAB, that means ABC. Here also CAB, that means ABC into A plus B. So actually the determinants will become this, but I said when we are applying this elementary operation, that is when we are multiplying rows or columns by some constant, we also have to divide the determinant by that constant. So as we have multiplied R1 by A, so we have to divide by A. Similarly, we have to divide by B and also we have to divide by C. That means we have to divide the whole determinant by A, B, C. So remember this, don't forget this. If you apply this operation, that is if you multiply some row or column by some constant, then also you have to divide the determinant by that constant. As we have multiplied all the three rows by A, B and C respectively, so we also have to divide the whole determinant by ABC. Okay, now here you see that in the second column and in the third column there are all ABC. So from the second column we can take ABC out and it will become ABC into, also from the third column we can take ABC out as common. So after taking out ABC, we have ABC 1 1 1, B plus C, C plus A plus B. Now one ABC will cancel here, and here you see that the elements here is A, here is B plus C, here B, C plus A, here C, A plus B. So if you observe the elements carefully, you will find what? If we add these two columns, then all the elements will be same. You see that if we add these C1 and C3, then each element will become A plus B plus C, B plus C plus A, C plus A plus B. That means all are A plus B plus C. So we can apply that operation now. So here A, B, C, we are applying the operation C1 changes to C1 plus C3. So when we are giving column operation, write the elements column wise, and when you are giving row operation, you write the elements row wise. Otherwise, confusion will arise. Okay, so C1 plus C3, that means A plus B plus C, B plus C plus A, that is also A plus B plus C, C plus A plus B, that is also A plus B plus C, and the other columns will be as it is. Now look at this determinant. Here the first column has each element A plus B plus C. Now if we take this out as common, then we have A, B, C into A plus B plus C into 1, 1, 1, 1, 1, 1 in the second column. This will be as it is, B plus C, C plus A plus B. Now you see that the two columns, that is first and second column, has become identical. So the value of this determinant must be 0 by that property. If two rows or columns are identical, then the value of the determinant is 0. So using that property, we have ABC into A plus B plus C into 0. Why 0? You have to give the reason, since first column, that is C1, and second column, that is C2, are identical. So the answer will be 0. So let's go to the next example. Next example is without expanding, so that here also without expanding, so that 1, 1, 1, ABC, A square minus BC, B square minus CA, C square minus AB. This determinant is equal to 0. So now we have to show the value of this determinant is 0. Now you see that LHS, left hand side, is equal to what we can do here. If you find this is A square minus BC, that is if you find each of the elements are sum of two terms, then we can divide the determinants into two sub determinants. Okay, like 1, 1, 1, A, B, C, A square, B square, C square. This will be plus 1, 1, 1, A, B, C, minus B, C, minus C, A, minus A. There was a property that if each element is the sum of two terms, then the determinants can be written as the sum of two determinants like this. Now this determinant we will keep as it is, first determinant. And here from the third column we can take -1 common, so this sign will become minus. Now this determinant we can multiply each row by a, and sorry, the first row by a, the second row by b, and the third row by c. Then what will come? But as I said, when we multiply the determinant, multiply the row by some constant, we also have to divide. So we have to divide by a, b, c. Multiplying the first row by a, we have a square, a, b, c, b, b square, and here also a, b, c, c square, here also a, b, c. So the operation here is R1 multiplied with A, R2 multiplied with B, and R3 multiplied with C. And as we have multiplied, so also we have to divide. Now look at this determinant. Here we can take ABC out from the third column. So what will come? We have 1, this will be as it is, a square, b square, c square, minus if ABC is taken out common, then we have ABC divided by ABC, a, b, c, a square, b square, c square, and 1, 1, 1. Now this ABC and ABC will cancel out, and this will be as it is. Now look at this determinant. This column, that is C3, if we can pass it over the first two columns, then it will be same as this determinant. And we all know that by a property, if we pass over, if we want to pass over a particular column by two columns, then we have to multiply it with -1 whole to the power 2. In general, if a particular column or a particular row passes over by m number of rows or m number of columns, then the determinant is multiplied by -1 whole to the power m. So here, if we want to pass it over, here you see that why I am passing the third column over the first two columns, because then it will become same as this determinant. So we have to multiply it by -1 whole square, because the third column C3 is passing over the first two columns, and it is becoming 1, 1, 1. If we pass the third column over the first two columns, it will become same as this 1, 1, 1, A, B, C, A square, B square, C square. Look at this 1, 1, 1, that is the third column has passed over the first two columns, and it is now same as this determinant. Now -1 whole square, that means +1, so that means it will be minus this, that is this determinant minus the same determinant. So the answer will be 0. So let's go to the next example. Next example is prove that a plus b, a plus b plus c, 2a, 3a plus 2b, 4a plus 3b plus 2c, 3a, 6a plus 3b, 10a plus 6b plus 3c. This determinant we have to prove is equal to a cube. All the sums that I am doing now are actually all exam questions. Okay, and this came in different years, so these are very important. Okay, so now how to solve this problem? LHS is equal to, you look at the elements of the determinant. Actually, where without expanding will not be mentioned, there you can expand at any stage, but don't try to expand the determinant at the very first step, because if you do so, the calculation will be very much complicated. So in this type of problem, our aim will be to make as many elements as possible 0. Okay, we have to make as many zeros as possible. So how we can make the elements as many zeros as possible? You see that if we subtract, here it is a, here it is 2a. So if 2a minus, if I subtract the, if I do this operation, r2 changes to r2 minus 2r1. Why I am doing this? Because you see that then 2a minus 2 into a, it will become 0. Similarly, if we want to make this element 0, then we have r3 minus 3r1. Why 3r1? Because when I am multiplying this by 3, it will become 3a, and 3a minus 3a, it will become 0. So you have to observe the elements. As I said earlier also, that observation is very much important in problems of determinants. If you look the elements very carefully, you can find the operations, which operations you have to apply, that you can find yourself. And here you have to try to make as many zeros as possible. And how you can do this? If we apply this operation, r2 minus 2r1, you see that second row it is 2a. So if I multiply the first row by 2, it will become 2a, 2a minus 2a, it will become 0. Similarly, it is 3a, so if I apply this operation r3 minus 3r1, then it will be multiplied by 3 and it will become 3a minus 3a, 0. So after giving the operations, we have the first row will be as it is, a plus b, a plus b plus c, 2a, 3a plus 2b, 4a, sorry, r2 changes to r2 minus 2r1. So 2a minus 2 into a, it will be 0. 3a plus 2b minus 2a minus 2b. So we have 3a plus 2b minus 2a minus 2b. So 2b will cancel. 3a minus 2a, it will become a. Now this will be 4a plus 3b plus 2c minus 2a minus 2b minus 2c. Now 4a minus 2a, it will become 2a, and 3b minus 2b, it will become b, and 2c minus 2c, it will become 0, so you don't have to write. Now 3a, r3 minus 3r1, so it will be 3a minus 3a, that means 0, 6a plus 3b minus 3a minus 3b, so 3b 3b will cancel, 6a minus 3a will become 3a, and it will be 10a plus 6b plus 3c minus 3a. 10a minus 3a is 7a. 10a minus 3a is 7a. 6b minus 3b is 3b, and 3c minus 3c will be 0, so you don't have to write. Now as this has become in the first column, as the two elements have become 0, so we can now expand by the first column. So we have expanding by the first column, we have a into 7a plus 3b cross multiply minus 3a into 2a plus b. So after simplification, this will be 7a square plus 3ab minus 3 to the 6a square minus 3ab. So plus 3ab minus 3ab will cancel out, and we have a into 7a square minus 6a square, that means a square. So we have the answer is equal to a cube. Now a cube has to be proved, so we have proved LHS is equal to RHS. So hope you have understood this problem. Now let's see the next example. Next example is also proof that a minus b minus c 2a 2b b minus c minus a 2b 2c 2c c minus a minus b. This you have to prove is equal to a plus b plus c whole cube. Solution. Here LHS is equal to, you see that a minus b minus c, here it is 2a 2a, and here it is 2b 2c. So if we apply the row operation here, that means if we apply r1 plus r2 plus r3, look at the elements very carefully. If we apply r1 plus r2 plus r3, then a minus b minus c plus 2b plus 2c, what will come? Minus b plus 2b will become plus b, minus c plus 2c will become plus c. So the element will become a plus b plus c. Here also you check b minus c minus a plus 2a plus 2c, minus plus 2a minus a will become plus a, 2c minus c will become plus c, and b is already there, so we have a plus b plus c here also. Here also you find c minus a minus b plus 2b plus 2a, so minus a plus 2a will become plus a, 2b minus b will become plus b and c. So here also we are getting a plus b plus c. So our target is to make all the elements in this type of problem where you can expand. In this type of problem, your target will be to make as many zeros as possible, and for that first we have to make all the elements same in a particular row or column if possible. So here it is possible if we add all the three rows. If we add all the three rows, then each element is becoming the same a plus b plus c. So we will apply this operation. R1 changes to r1 plus r2 plus R3. So after applying this operation, this will become A plus B plus C. This will also be A plus B plus C. And as I said, when you apply the row operation, write row wise. Then there will be no confusion. Okay. So A minus B minus C plus 2B plus 2C will become A plus B plus C. Similarly, this will also become A plus B plus C. And this will also become A plus B plus C. And the other elements you keep as it is. Now, once we have got all the elements same, we can take it out as common. A plus B plus C can be taken out common, and we have 1, 1, 1, 2B, B minus C, minus A, 2B, 2C, 2C, C minus A minus B. Now, once we have got 1, 1, 1, then we can apply column operation, like that is subtract the two columns here, C1 minus C2, then it will become 0, and C2 minus C3, then this will become 0, and we already will get 2 zeros, and after getting 2 zeros, it's you will expand and you will get the required result. So we have, after this, A plus B plus C. We apply C1 changes to C1 minus, C1 changes to C1 minus C2, and C2 changes to C2 minus C3. So giving these operations, we have 1 minus 1. You see here I have applied column operations, so we have to write column wise. 1 minus 1, 0, 2B minus B, that means B, then minus minus C, that will become plus C, minus minus A, that will become plus A. So B plus C plus A, that means A plus B plus C. Here you see 2C minus 2C will become 0. Next, C2 minus C3, 1 minus 1, 0, B minus C minus A minus 2B, B minus 2B will be minus B, then minus C minus A. So that means minus B minus C minus A. If we take minus common, we have minus B plus C plus A. That means minus A plus B plus C. Then 2C minus C, that means plus C. Then minus minus A plus A, minus minus B plus B. So C plus A plus B, that means A plus B plus C. And the remaining column, third column, you could write as it is, 1 to B, C minus A minus B. Now, once we have got 2 zeros in the first row, then we can expand. And we will get expanding by the first row. We get 1, 0, 0, you don't have to write, only 1 into this cross multiplication, this into this minus 0 into this. 0 into this means 0, so this into this will remain only. So we have 1 into A plus B plus C into A plus B plus C minus 0 into this, so minus 0. And after simplification, this will become A plus B plus C whole square into 1, so A plus B plus C whole square, and A plus B plus C whole square into A plus B plus C, that means A plus B plus C whole cube, and this was to be proved, so is equal to RHS proved. Okay, so that's all for now. Let's see you in the next video. Till then, bye.